Find the sum 1 minus 1/2 plus 1/4 minus 1/8 plus ... all the way up to minus 1/512. So if we look at this, this is actually a partial sum of a geometric sequence. If you look at the individual terms here, we've got 1, negative 1/2, 1/4, negative 1/8, etc. And to get from one term to the next, we multiply by negative 1/2. For example, 1 times negative 1/2 is negative 1/2. Negative 1/2 times negative 1/2 is positive 1/4. Positive 1/4 times negative 1/2 is negative 1/8, etc. So this is a partial sum of a geometric sequence, which means we need to use the formula for the partial sum of a geometric sequence, which is S sub n equals A times the quantity 1 minus r to the n over 1 minus r. In this case, we notice that the first term is 1, so it's going to be 1 times this whole fraction, and we said the common ratio was negative 1/2, so it's going to be 1 minus negative 1/2 to the n all over 1 minus negative 1/2. Now we can actually simplify the denominator. 1 minus negative 1/2 is the same as 1 plus 1/2, which is 3/2. So we can write this as 1 minus negative 1/2 to the n all over 3/2. This is the formula for the nth partial sum. Now we actually need to figure out which partial sum this is, or how many terms there are. Now if we look at the denominators, these are all powers of 2. In particular, for the negative 1/2, the denominator is 2 to the first. For the next one, it's 2 to the second. For the next one, it's 2 to the third. In fact, the original term, 1, we could write as 1 over 1, and that's going to be 2 to the 0 power. So we go all the way up to 1 over 512. And so we want to know what power 512 is of 2. And I am literally going to count these out on my fingers. The powers of 2 are 2, 4, 8, 16, 32, 64, 128, 256, and 512. So 512 is 2 to the 9th power. Took me a second to calculate that out. There are other ways of doing this. You can use a calculator and you can keep multiplying by 2 until you get to 512. But in general, doing this shows us that there are actually 10 terms. Because if we start with 0 and go all the way up to 9, we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 terms in total. And so what we need here is we need the 10th partial sum. So this is going to be 1 minus negative 1/2 to the 10th power over 3/2. Now, negative 1/2 to the 10th power is going to be positive 1 over 1024. You can easily do this with a calculator. 1 to the 10th power is 1. 2 to the 10th power is 1024. This is all over 3/2. Now, to take 1 minus 1024, we need to write 1 as a fraction, and we need a common denominator. The common denominator is going to be 1024. So we've got 1024, 1024ths, minus 1 1024th, all over 3/2. In the numerator, when we subtract these fractions, that gives us 1023 1024ths divided by 3/2. We know that dividing something by 3/2 is the same as multiplying it by 2/3. So we can multiply this by 2/3. And we can actually do some cross-canceling here. I know these fractions are a little bit painful because the numbers are so large, but we can do it. 1024 and 2 are both divisible by 2. When we reduce, that gives us 1 and 512. Now, 1023 and 3 are both divisible by 3. When we reduce by a factor of 3, we get 341 and 1. And so when we multiply across, we end up with 341 over 512. And that is our final exact answer. It probably seemed like a lot of work. However, it would be less work than figuring out what all of these fractions are, getting a common denominator for all of them, figuring out the numerators, the equivalent numerators for all of them when we rewrite them with a common denominator, and then doing all of that arithmetic. I know this seemed like a lot of work with some very large numbers inside the fractions, but this ends up being probably the easiest way to find the sum.